Hello, my name's Guy Armstrong. This video is based on my own personal research, and although I talk about other people's research. This video is about Dr. Muriel Bell and her exaggeration of fluoride's essentiality. If you like or dislike this video, feel free to leave a comment on my Facebook page there, or if you have any questions or want me to elaborate on anything, you can go for it. I'm the author and publisher of this book, How Essential is Fluoride, which demonstrates that one of the claims or presuppositions or beliefs consistently made over the last 70 years by advocates of fluoridation, the claim that fluoride is an essential nutrient, has been exaggerated. What do I mean by exaggerated? Well, I'm talking about the behaviour of professional public health experts and dentists and scientists and media who've been advocating fluoridation over the last 70 years. Here's just a few bullet points, and these are kind of general, and there's always exceptions to every generalization. So these are general. Not publicly mentioning in media any experiment that concluded fluorine or fluoride non-essential, even when funded or performed by people who advocated fluoridation of water supplies or people who were not involved in promotion of or opposition to the fluoridation of water supplies. Not publicly mentioning in media that a piece of technical literature authored by groups or organisations advocating fluoridation of water supplies had concluded fluorine or fluoride non-essential. Claiming that fluorine was an essential element with very little discussion or critical thinking. Fluorine was considered essential simply because experts said it was. So wherever you look, there's an expert saying it's definitely an essential nutrient, just like iodine and so on. And everybody says that's true because there's some other expert saying it, and then everybody just acts like it's definitely true. Ignoring contradictions on this matter in technical literature and experiments, using the spurious term fluoride deficient to describe any water supply with less than 1 part per million fluoride without stating that no fluoride deficiency had been demonstrated in humans. Saying the question of essentiality did not matter when opponents of fluoridation pointed to research that had concluded fluorine a non-essential element, even when that research was funded by advocates of fluoridation. All of these are discussed in my book, which strikes a firm blow to the idea or belief that experts are objective and neutral. This video will focus on Dr. Muriel Bell's claim that fluorine or fluoride was essential. This is the recent biography of Dr. Bell, published in 2018, authored by Otago University historian Diana Brown. I write quite highly of it, and I think it's a really important book. I believe Muriel Bell was a very hardworking and intelligent researcher, and I think we were very lucky to have her in this country. Her concern for people was obvious. She was one of the most influential advocates of community water fluoridation in New Zealand. So I'm very happy to admit she's probably a very wonderful person in many ways, but I obviously disagree with her on the fluoridation things. Her writings compare fluorine to iodine and vitamins and other essential factors. I want to thank author Diana Brown for being open to sharing some of her ideas and research with me when I asked. I think she did a fantastic job representing Dr. Bell's claims and work. Well, Dr. Muriel Bell was heavily influenced by American experts such as Professor Elmer McCollum and Dr. Frederick Stair, who I discuss in Chapter 5 and 6 of my work, both of whom are mentioned in Brown's book. And Dr. Bell was co-author of one chapter of the 1970 World Health Organization monograph, Fluorides in Human Health. This is a newspaper clipping here just demonstrating Dr. Bell is comparing fluorine or fluoride with vitamin A, D and K in the sense that she believes there's a deficient amount, a normal sort of amount that the body needs, and then an excess, so just like any normal nutrient. And this is her paper, Medical and Nutritional Aspects of Fluoridation. She does basically the same here, but she elaborates a lot. This paper's, 10 or 20 pages long or something. And here she's talking about vitamin A, and she says, fluoride's just like vitamin A and so on. Well, looking at Dr. Brown's book, this is, we can see some of Dr. Bell's understanding here. After reading a paper showing that fluoride hardened the teeth of rats, she suspected a deficiency in fluoride might be a contributing factor. So reference number 21 is given, and that's the study here, E.V. McCollum and so on. The effective additions of fluorine to the diet of the rat on the quality of the teeth, Journal of Biological Chemistry, 1925. Well, I'll summarise the introduction here. The authors of this experiment claimed slight confusion regarding the effects of rat diets. The teeth of some animals did not appear to have any problem until later in life, while others had a lot of decay early in life without the diet appearing defective in any way. So they're talking about the experiments that they've done over the previous few years. The scientists suggested that since many investigators before them had found fluoride in teeth and bones, deficiencies of the element may be a distinct possibility. They believed that because teeth had a high content of fluorine, it may have been one of the structural components of dentin. Note that this is the hypothesis presented at the beginning of the experiment. It's not the conclusion. I believe this experiment will not satisfy the most critical of scientific inquiries with regard to any definite conclusion of essentiality, because it did not demonstrate the existence of the deficiency state. In order to demonstrate an element or compound's essentiality, you need to demonstrate a deficiency state, and this is expressed in a few studies or a few pieces of work that I quote in chapter 1 of my book. Here is one of these pieces of work. This is Dr. Messer and his co-workers from the University of Minneapolis in Minnesota, and this is just a really concise little way to put it. A specific deficiency state should be produced by a diet lacking the element in question, but which is otherwise adequate and satisfactory. So normally in these kind of experiments you'd have two populations, and one of them would lack the element or compound that you're testing in their diet, and the other one would have the element or compound, and sometimes you have many populations with differing amounts of that element or compound in the diet, but the other nutritional, the other factors are still there. So quoting McCollum and his co-workers in 1925, "We have in no instance attempted to control the intake of fluorine in any of our experimental animals, so that the amount of fluorine ingested may have varied over a wide range depending upon the nature and amount of natural foods in the diet. Our diets in many cases consist in considerable measure of purified foodstuffs, so the amount of fluorine ingested in these diets was very small." No number is given for very small. Quoting again, "We tried the inclusion of 226 part per million of this element in the form of sodium fluoride. We report at this time only the results of feeding a diet which produces good teeth and of feeding the same diet with fluorine addition. The results showed, contrary to our expectations, that the ingestion of fluorine in amounts but little above those which have been reported to occur in natural foods markedly disturbs the structure of the teeth." So one group of rats, lot 3623, had unknown amount of fluoride in diet plus 226 part per million sodium fluoride in water. The other group, lot 3619, had an unknown amount of fluoride in the diet and no added fluoride in the water. And I would agree with you if you said this 226 part per million, that's a lot of fluoride. How much is that for a rat? So let's have a look at rodent tolerance for fluoride, or maybe this is better worded as food, but fluoride concentration in rodent food. Rats have a pretty massive tolerance to fluorine. So Dr. Wallace Armstrong said commercial rodent food contains between 40 to 60 part per million. Ofog and McGill wrote a control group was fed commercial rat chow with 20 to 60 part per million fluoride. Well, 226 part per million is just under 4 to just over 11 times what rodents would get in their normal lab or commercial diet, and there's the references down there. Those rats fed diet 3619 had excellent teeth, so that's unknown amount of fluoride in the diet, no added fluoride. The animals fed the added fluorine were slightly stunted in that they never grew so large as the controls, and they were shorter and more stocky. It was observed that the rats fed the diet of lot 3623 developed incisors which were abnormal in colour, the orange tint seen on the anterior surface of the incisors in normal rats being nearly absent. These teeth were also observed to grow into abnormal positions, the upper ones tending in nearly every case to grow backwards into a circle, finally penetrating the roof of the mouth because they were not worn down by attrition. I'll show some pictures of this soon. The abnormalities of the incisors were evidently due to changes in their structure and hardness, since the lower incisors tended to wear away too easily and the upper ones occasionally broke off, leaving a blunt end. The teeth were of a special interest to us in connection with the development of a general plan of study of the relation of the diet to dentition. Accordingly, we submitted the skulls of certain animals typical of the collection made to us by Dr. R.W. Bunting of the University of Michigan for description. His report is as follows. In a comparison of the skulls of the rats under the fluorine treatment with those on normal diets, it is apparent that certain marked changes in dental and osseous development have been produced by even the slight modification of the normal diet. From their general appearance, the bones of the experimental animals do not seem to be as good in quality as in the normal animal. The skulls appear whiter and their surfaces are manifestly more porous and lack the characteristic luster of normal cortical bone. The rami of the mandibles are somewhat thinner and less prominent than those of the controls. In the maxillae, the dental arches of the fluorine rats are fully 1 mm narrower in the molar region than those of the normal rats. That's figures 1 and 2. In the mandible of one experimental rat, there is an osteoporotic affection of the alveolar process about the third molar, which caused that tooth to drop out of its socket. So on the left, normal rat; on the right, rat-fed sodium fluoride. This is figure 3. The most notable characteristic of the fluorine rats is a marked overgrowth of the maxillary incisors and a corresponding shortening of the mandibular incisors, which elongated in a curved fashion to form an arc equivalent to the greater part of the circumference of a circle. So if you're interested, you can get the experiment yourself. I obtained it for free from the journal's website. Here you can see the rats, the sodium fluoride-fed rats above and the controls below. One reason for the elongation is given. Rat incisors grow about 2.5 mm a week and are worn down by chewing or attrition. I should add here in the book, in the first print run of 40 copies, I think I made the mistake of saying they grew this much daily, 2.5 mm daily. Well, that was an honest mistake, so I apologise. They grew this much weekly according to this experiment, and subsequent copies have been updated, of course. So if you buy a copy now, it'll be updated to include this, the changes of... Anytime I find a mistake, I just update it, and I've hardly found any. So that's good news. Well, 226 part per million. Oh, hang on, I'll continue reading this. This is page 560 of the 1925 experiment. The mandibular incisors in one rat have been so severely eroded that the exposed portions of the teeth have been reduced to a level with the gum line. These teeth in the other rat were also excessively worn down, but not to the same extent as in the former. These teeth in the other rat were also excessively worn down, but not to the same extent as in the former. In the latter case, the lower incisors were spread widely apart so that they did not come into normal incisal occlusion with their maxillary opponents. That means that when the teeth are chewing like this, and teeth are coming down on each other, they're missing like this. From even a macroscopic examination of the incisor teeth of the experimental animals, it is quite apparent that they are inferior in quality to those of the normal animals. They are of a dull, opaque white colour and lack the natural polish of well-formed toothless substance. In certain areas they are corrugated transversely, suggesting intermittent interferences with development. These departures from normal are more apparent in the mandibular incisors, being marked by a wide separation of the teeth and an extreme friability which causes these teeth to be seriously eroded by contact with the maxillary incisors. At first sight it might be inferred that the great overgrowth of the maxillary incisors has been caused by some stimulative action of the fluorine on the activity of the tooth-formative organ. This incisal overgrowth, however, may be accounted for in another way, namely by the lack of the natural wear which the incisors of the rat under normal conditions exert on each other in occlusion. Donaldson estimates the normal growth of the incisors at 2.5 mm a week, which amount the adult rat must wear down by incisal attrition to maintain his teeth at the normal length. If for any reason this incisal reduction by wear does not take place, well, they continue and continue. Excuse me, it's quite a long experiment, or, write-up. Now, 226 part per million put into rodent water probably has very little bearing or relevance to 0.7 to 1 part per million added to human drinking water. So it's quite weird that this is the only experiment, with maybe one or two exceptions, that both myself and Diana Brown, two completely unrelated researchers, had found that Muriel Bell talk about with regard to her claim that fluorine was a nutritional essential. There were other experiments she could have talked about, but she didn't, except there's one that I'll mention, or maybe there's one or two. But very few, and this is pretty standard. I share this to point out that this experiment does not meet the requirement of being a deprivation experiment that minimises exposure to fluoride, because we don't know how much fluoride was present in the diet of either group. So I think Dr. Muriel Bell's claim that this experiment demonstrates an essential role for fluorine is a little imprecise. Well, there's another point here that needs to be made, which is that I haven't seen anyone else use this experiment as evidence or even suggestion of essentiality. And I don't want to suggest to you here that Muriel Bell was a fanatic about this. She was a thoughtful, sensible lady, and I think she sort of used this experiment to sort of take a step of logic to conclude fluorine essential, but she certainly did not go into a big detail about all the warpings of the teeth. None of the other experiments looking at this topic, is fluoride an essential nutrient, are discussed in Diana Brown's biography. None of the other experiments looking at this are discussed. And this is a mostly accurate representation of Dr. Muriel Bell's work. When I looked through her research, it was the only experiment that I found reference to, except for one more, the 1945 McClendon research, which is discussed in my book. So this is the New Zealand Dental Journal. Dr. Bell and Dr. Harrison writing, and they write, McClendon and Foster found that rats on a fluorine-free diet lost practically all the crowns of the first and second molar teeth. It's too early to make pronouncements on studies of this type, but they offer the hope that the study of the initiation of caries and its control may lead to a practical outcome in the not-too-distant future. If you get that experiment, it's less than a page long. It's only a handful of rats, less than 10 rats, and it's funded by the Aluminium Company of America. Well, discussion of fluorine deficiency in Brown's book is present. This is understandable given that she kept purely to Dr. Bell's research, writing an opinion, and it is so easy to find conflicting claims in scientific literature. So I don't blame Brown for avoiding modern statements. I must point out that in her work there is no discussion on recent or current claims regarding the words of bodies such as the EFSA, the European Food Safety Authority, or SCHER, Scientific Committee for Health and Environmental Risks, disagreeing with Dr. Bell's claims of a nutritional role for fluorine, which she definitely did make in newspaper clippings and so on, or newspaper articles and letters and stuff. In one sense, this is fair enough, as it would have detracted from her focus on Dr. Bell. Diana Brown told me she carried out her research in 2005. This will partially help to explain the lack of modern statements regarding claims of deficiency. But I believe a resourceful researcher like her would not have missed these comments if the New Zealand media had publicised them. So the modern reader is rescued from the discomfort of contradiction. And the larger point I want to make here is not that one particular researcher should discuss them, it's that nobody discusses them in public, not even the opponents of fluoridation most of the time. So no signs of fluoride deficiency have been identified in humans. A lack of fluoride intake during development will not alter tooth development, but may result in increased susceptibility of enamel to acid attacks after eruption. However, caries is not a fluoride deficiency disease. Well, that's the European Food Safety Authority journal, and this is cited. This document is cited in the paper commissioned by Sir Peter Gluckman and Sir David Skegg in 2014. But this statement, these two statements here, are not quoted in the Skegg and Gluckman work. Excuse me. So here's the citing of the European Food Safety Authority. Two reviews of Diana Brown's book ignored recent statements on this topic. The New Zealand Journal of History and the Otago Daily Times. Of the American influence on necessity and deficiency, or I should say claims of necessity and deficiency, I have not found anything to suggest that New Zealand experts in the 1950s knew anything of the experiments other than the 1925 McCollum experiment and the 1954 and 45 McClendon experiments. The McClendon also did an experiment in 1954. The write-up is much bigger than the 1945 one. Again, it was funded by the Aluminium Company of America, and it's quite a bizarre, unique experiment. I talk about it a lot in my book, maybe not a lot, but a bit. it's pretty interesting experiment. Of course, the aluminium company is, funding experiments into fluoride because it's a massive pollutant. And I share a ton of newspaper articles and even some academic articles looking at that sort of thing. Well, regarding water fluoridation, it's not discussed by anyone, but in 1944, one of Dr. Bell's listener articles claimed that 1 to 2 part per million was excessive. I'll show you this in the next slide. This is something of an aberration because all the rest of her work claims CWF at 1 part per million to be safe and effective and so on. This is the listener article. In certain areas of the USA and elsewhere, in the presence of more than 1 or 2 parts of fluorine per million parts of water in the reservoirs serving certain areas was attended by an ugly mottling of the enamel. The teeth became pitted and discoloured, and in severe cases dental decay occurred in these teeth. This was due to the toxic effect of too much fluorine. Note that she's saying 1 to 2 part per million there. Well, she changed her tune. I want to say I've never seen this discussed by anyone. It's kind of an outlier. All the rest of her work is saying, 1 part per million is perfectly safe. In 1958, she wrote in a letter to a newspaper editor that fluorine was almost harmless in concentrations as high as 14 part per million. It's naturally occurring, excepting fluorosis, which she claimed did not occur at 1 part per million. This change in opinion was caused by her studies in America in the early 1950s. In her paper, Medical and Nutritional Aspects of Fluoridation, she discussed work done in Bauxite, Arkansas, claiming that American doctors would have noticed any adverse effects from people who were using 14 part per million fluoride in water. There was no mention of her listener article in this paper, Medical and Nutritional Aspects. This possibly demonstrates an American influence. Surely some of you will be aware of the editorial in the October 1944 issue of the Journal of the American Dental Association that began by expressing a very positive outlook for the future of community water fluoridation, which began in January of 1945. Though a couple of pages later, in the editorial claimed, "We do know that the use of drinking water containing as little as 1.2 to 3.0 part per million of fluorine will cause such developmental disturbances in bones as osteosclerosis, spondylosis, and osteopetrosis, as well as goiter, and we cannot afford to run the risk of producing such serious systemic disturbances in applying what is at present a doubtful procedure intended to prevent development of dental disfigurements among children." Well, this is the listener article a week later, and she's basically saying here that 1 part per million is perfectly safe, or whatever, or something. Or she's talking about. Well, I'll just read it to you. The correlation is illustrated by the fact that 2 cities in Illinois with domestic water supplies containing 1.8 part fluoride per million showed only 1/2 to 1/3 the dental caries rate that was found in 2 nearby towns where the water supply contained 0.1 to 0.2 part per million. Again, North and South Shields in England on opposite sides of the Tyne with 0.25 and 1.4 part per million in their respective water supplies show a dental caries incidence of 2 to 1 in 12-year-old children. I think there's a real danger of ignorance here regarding the effects and necessity of many other elements and compounds that affect teeth in only looking at fluoride concentration. Well, here's some more about the American influence. Many letters in the Health Department and other archives demonstrate a consistent communication with American fluoridation promoters. I often wonder how we would have approached fluoridation in this country without Uncle Sam's instruction and guidance, and how different the journalism could have been. This is a letter dated 14th March 1961 from the Deputy Director General of Health to Dr. Bell asking about fluoride tablets, and Dr. Bell wrote back in the 21st of March discussing the instructions should be made clear that only half a tablet should be given up to the 3rd birthday. That is on the advice of Dr. Arnold, Washington. Everyone who studies fluoridation will know Dr. Arnold. This is back in the 1950s, Dunedin Evening Star, and this gives us a bit of an insight into the American promotion. Dr. Muriel Bell, Director of Research Work in the Nutrition Research Department at the University of Otago Medical School, said she had approached Professor Frederick Steer, head of the Nutrition Department of the Harvard School of Public Health, Boston, United States, whom she had named previously as one prominent scientist who would unequivocally support fluoridation. In a reply, Professor Steer had stated, "Certainly fluoridation of public water supplies is one of the most intelligent and forward steps in public health of this generation." Dr. Bell had given evidence to the Commission in the North Island, but put forward additional evidence today. She said Professor Steer had also enclosed a statement by Dr. Norman Jolliffe, who was a member of the Food and Nutrition Board of the National Research Council USA. So we have a real heavy influence from the United States, of the US promoters of fluoridation here in New Zealand. Now this is a rather right-wing sort of business journal, Chemical Week. It's been around since 1914. It's still around today. So they like to write about industry, and this is back in the 1950s, and they're always really happy whenever some rich businessman makes a lot of money, or whenever the chemical industry has a success. And they had weekly publications in the 1950s. They write really enthusiastically about business and money and so on. So I know it's like a really happy publication, but it's also really clinical and dry in a sense. So this article is about the sugar industry and the sugar sweetened beverages. Of course, they used to call it pop back in those days. And this article is discussing how the sugar industry in America was a little worried. They only had 99.4% of the market, I think. So because the no sugar varieties rack up a mere 0.6% of the total 1 billion case stack of pop, their existence and growth can still be viewed by sugar makers as a relatively minor ripple. As insurance against future loss of business to synthetics, Sugar Makers Sugar Research Foundation is directing a $600,000 fund for a big-scale rebuttal to the claims of non-sugar foods. Guiding association member Educational Advertising, pointing out that sugar singled out as fattening is, after all, no more calorie adding than such publicly approved diet foods as tomatoes or grapefruit. Only last week, Thursday, the directors of SRF voted to continue a $27,000 a year research project under the direction of Dr. Frederick J. Steer, Nutrition Department head at Harvard, to discover whether or not non-nutritive sweetening agents are of value in reducing diets. I think by reducing diets they mean losing weight. Diet change. According to an SRF spokesman, Steer's results could go far toward changing present-day thought on reducing diets, particularly with regard to cutting down on sweets. In a preliminary study recently completed on rats, Steer tentatively concluded that an important, probably determining factor in combating the sense of hunger is the raising of the concentration of sugar in the blood. Conclusions, if verified by Steer by way of his newly authorised studies on human subjects: when you're hungry, reach for a sweet, uncontaining sugar, of course. Sugarless drinks and foods serve no dietary purpose. The body still requires the same amount of food because it has not assimilated any sugar. Quite understandably, the sugar suppliers are interested in establishing proof of Steer's hypothesis. Such results, 1, would remove the fattening stigma from sugar, and 2, could lead to increased sales. Well, one reason I said some good things about Muriel Bell at the start of this little blah blah was that she did not share Dr. Frederick Steer's enthusiasm for sugar, so she sort of cautioned against it a bit. Well, you only need to walk down the street in Wellington City, where I lived most of my life, and you can see billboards and, the size of, a floor of a building or whatever, advertising sugary products. And no doubt that sugar causes a whole pile of dental decay, but we've also got to be aware that replacing it could possibly lead to replacing it with something even worse. This is me summarising some work from Kearns, Schmid and Glantz from my book. They wrote, Reflecting the research priorities of the sugar industry, the 1971 National Carries Program research priorities ignored strategies to limit sugar consumption and focused instead on fluoride delivery, reducing the virulence of oral bacteria, and modifying food products with additives to counter